thing you have to do is write the value of your variables. In this exercise, we are going to add the value of both algebraic functions. We have x plus 2 and x to the second power plus 1. Count the exponents and order all your numbers so you can add them. To finish this operation, just order all your numbers by the exponents. This next operation is basically the same, but instead of adding all your numbers, you are gonna subtract them. We have the same values, x plus 2 and x to the second power plus 1. Take out the parentheses and start doing your subtraction. Remember that equal signs add and different signs subtract, so you gotta be very careful. And remember, the sign that stays is the one that has a bigger number. In this operation, we are going to multiply them. Here you will multiply your x plus your x to the second power and your 1. Then you're going to multiply your 2 to the x to the second power and your plus 1, so you can get the result. Now that you have that result, you're gonna add your numbers that are equal, or your numbers that have the same exponent or base. Here you can see I left a 1 by the x, but we already know that when we have an x alone, this means we already have a value of 1, so we take out the 1 and just leave the x. Finish, just order your numbers by the value of their exponent and you're done. Here we're going to divide both of our values. Here you have to order your values so you can do the division. Here I'm doing a long polynomial division. You can do whatever polynomial division you want. I'm just doing this one because I'm more comfortable with this. So here I'm showing you that we are missing one value. So what we're going to do is just add a 0x so we can do the division. Now that we have all our values, we can start the division. So what value gives us x to the second power? We already have an x, so we need another x. So x and x gives us x to the second power. Then you do the x times 2, and this gives you 2x. Remember that when you are doing this type of division, you change the value of your sign. So if you had a positive sign, you change it to a negative. And if you have a negative sign, you change it to a positive sign. Then you add or subtract your values and do the next number you're missing. So ask you the same question: what value gives us the value we need? So you're going to do that, and remember, your signs change, so be very careful at this situation. Then you add or subtract your values so you can get the remainder of your operation. To find this value, you are going to need to follow the next rule. This is how you need to order all your values so you can get the value. Basically, we put our parentheses and our x to the second power because that represents our g. Then you're going to close that parenthesis and put your plus 1, and then you're going to do that in the same parenthesis, x to the second power plus 1 and your plus 2. And with that, you're done. You just have to order it so you can solve it. Here is almost the same procedure as the last one, just a little bit different. Remember that you have to order all your values in the order that it needs to be, because in other cases, you're not gonna get the value. In the parentheses, we have x plus 2, and this is going to be to the second power plus 1. Then you're going to do this operation. So your result will be x to the second power plus 4x plus 4, you close your parentheses, plus 1. And now you do your values. So it's x to the second power plus 4x, and your 4 and your 1, it's going to be plus 5. And you're done. Here we're going to divide our last value times the x plus 2. So you write down your GOF value divided by your fx value. In this case is x times 2. Remember, you can use different polynomial divisions. In this case, I'm using a long polynomial division. Remember to ask what value gives me the value I need. In this case, we need another x, so we can get an x to the second power. And so on, you do your next value and then your next until you're finished. Remember that your signs are going to change, so be very careful.
Firstly, we are going to write our problem that will consist of 5 letters with different coordinates. Coordinates for A will be 9, 8. For B will be -3, 5. For C will be 3, 3. For D will be 1 minus 4, and for E, -7, -9. We're going to calculate the domain range, so D and R stays for them. The domain represents the x-axis and the range the y-axis. That's why, for the domain, we are writing the first number of each coordinate. And for the range, the second number of each coordinate too, because the first number represents the x-axis and the second number the y-axis. A very important point is that no number can repeat in the domain, because if it does, it wouldn't be a function. On the other hand, in the range, the numbers can repeat and it doesn't affect the function. At the end, our domain will be 9 minus 3, 3, 1, and minus 7, and our range will be 8, 5, 3, minus 4, and minus 9. Now we are going to graphic our coordinates. We will mark a point on each coordinate of this Cartesian plane. Also naming each point with the letters that match each coordinate. Finally, we are just going to connect all the points we marked. And that is how our graph will result. We are going to make one more example so we can be clear enough. Now, our coordinates will be minus 8, 7 for A, 8, 6 for B, 5, minus 7 for C, minus 4, 2 for D, and 2, 5 for E. We are going to write our domain according to the numbers that represents the x-axis and our range with the numbers that represents the y-axis. At the end, our domain will be minus A, 8, 5, minus 4, and 2, and our range will be 7, 6, minus 7, 2, and 5. We're going to graph these coordinates too. That's how this graph will result. Now we are going to move on with the following topic.
In the next clip, I'm going to show you how you can determine from a graph if it represents a function or a relation. The way we know if it's a function is if we draw a vertical line in the equation and it only touches one point. In a relation, it touches two or more points. In this example, we draw the equation in a graph. Then we draw a vertical line in any part. Here, it is only touching one point. Therefore, it's a function. Here's another example. First, we draw the equation on the graph. Then we draw a vertical line, and here we can see that it is touching 2 points. This means it's a relation. Now, I'm going to show you how you can determine the domain and the range of an algebraic function. First, I'll do an example of a linear function. We have x plus 5. We have to do a table where we can give x a value and do the function. Now, we can see that when you give a real value to x, it works. So, we know the domain and range can go from a negative infinite number to a positive infinite number. To graph a linear equation, we only have to put the values on the table we used and use the fx as our y, and this is what we get. Now, I'm going to do a quadratic function example. To determine the domain, we have to do the same thing as the linear function. So here, we know it can go from a negative infinite number to a positive infinite number. To determine the range, you need to do some procedure, which is to find the vertex that represents h and k. We calculate the h by dividing the negative form of the second term of the equation by half of the first term. In this case, it gives us negative 3.5. Then, to find the k, we have to substitute the variables in the equation by the value of h, which is negative 3.5, and here it gives us negative 6.5. Now we have the vertex, which is negative 3.5, negative 6.25. To find the range, we need to know if the first term in the equation is positive or negative. If it's positive, you put the value of k first and then an infinite symbol, and if it's negative, we need to put a negative infinite symbol and then the value of k. Since the value of the first term, which is x of this example, we put the value first and then the infinite symbol. Now, to graph, we need the values we just got, so it's important to write them down. Then, we need to find the factors of the function. Here, we get x plus 6 and x plus 1. But to find the values of x, we need to pass them to the other side, so one value is negative 6 and the other is negative 1. We also need to find the value of y. For this, we need to substitute all the values of x by 0. We do the operation and we get 6. This is all the data we got. Now, we're going to use them as coordinates to graph them. And this is what we get.
Firstly, we are going to write our first problem, and this will be the square root of 4x plus 20. We have to remember that the solution of this square root function will be different because this is a linear equation. Okay, so now having cleared this, we are going to calculate the domain and range of this equation. Input, we can know our range will be 0 infinite, because our principal term, that in this case is 4x, is positive. If in one case there were a negative sign out of the square root, our range will be minus infinite 0. So knowing this, we just write our range. Then, we're going to start our process by only using the equation inside the square root. And we are going to condition it to be greater than or equal to 0, and we are just going to isolate x. Since 20 has a positive sign, we are going to pass it to the other side with the opposite sign, so it will be 0 minus 20. Then, as 4 is multiplying by x, we are going to pass it to the other side, and minus 20 will be divided by 4. At the end, we will have the condition that x should be greater than or equal to minus 5. We can check this by using values greater than minus 5, and all of them gives acceptable values. So now our domain will be all real numbers x such that x is greater than or equal to minus 5. Now we're going to record this data in our graph. We will mark the minus 5, and this line will go from minus 5 x-axis to infinite, how it's represented on our range. And that's how our graph will result. It's important to know also that if there were a negative sign outside the square root, the line of the graph will go down. We are also making one more example. Now, our problem will be the square root of x quadratic plus 18x plus 81. And since our principal term is positive, we can write our range since this moment. As we can get the factors of this equation, we are going to get them. In this case, our factors will be 9 and 9, because 9 plus 9 is 18, and 9 times 9 is 81, so it meets with the equation given. As we have x plus 9 two times, we can just simplify it to have the square root of x plus 9 to the second power. And since we have the exponent and the square root, we have to cancel both. Then, it will just stay as x plus 9 and we will condition it to be greater than or equal to 0. And as in the first example, we have to isolate x. In this case, we just have to pass the plus 9 to the other side with the opposite sign, and as a result, we got x greater or equal than minus 9. We are going to graph this equation too in this Cartesian plane. And we will complete our domain by the expression last explained, but at the end, we will write the minus 9 we got as a result. The solution of this square root function was also different because this is a solution for a quadratic equation. Now, we will go on with a different topic.
Remember that in this case the domain is always x, such as x belongs to all real numbers except the number you're gonna get in your vertical asymptote. Remember, you're just gonna focus on your x minus 3 value because we don't need the 1. To find the value of this x, we are going to put x minus 3 equals 0. And then you're going to move your 3 to the other side. And this would be x equals to 3, because remember, your sign changes. Now that 3, we put it in our domain, and our vertical asymptote value is x equals 3. And you're done. Now we need to graph this. Here I'm just putting the values in the graph that I will need. In this case, our vertical asymptote is 3, so we cannot touch 3. We can get as close as we want, but we can never touch it. Your first line will come all around and it will get as close as it needs to be from the 3, but it's never going to be 3. And it is the same case for your other line. It's going to come from all real numbers, it's gonna get close to 3, but it's never gonna touch it, and then it's going to be the other way. Here I'm putting the line that you need to put because this means this is the line that touches 3. So you can get as close as you need, but you're never gonna touch it. With that, you're done.